Hey there, I'm SourceMake and welcome to part 6 of the Java series where we talk about classes. Now classes are really kind of hard, and when I first started programming, classes were the one thing that I just didn't understand. I took everything else that we learned so far and I really went wild with it, but classes just didn't make sense to me, and I'm going to try to talk about classes in a way that really lets you understand, so pay attention to the video because I'm going to teach it to you in a really good way. Maybe I didn't have a good teacher for it or I didn't learn about it online well enough, but I'm going to talk about classes good, well. And I'm going to do this part as just regular classes. In the next video, you're going to see why classes are good for object-oriented programming and why you expand around them, what objects are, stuff like that. So that's the next video. In this video, I'm just going to show you how classes work and why you would use them. So the reason you would use classes is because you want to create a blueprint for some functionality that you have that you want to use later. So for example, let's say we want to make a math library that is going to do some, I don't know, some calculations for us for this project, but maybe in another project in the future we want to use it too, or maybe we just want to structure our program in the way of classes. The way we're going to do it in this video is, let's say we want to make a math library that we're using for this project and maybe in some other project in the future. So we create that class in a file, and when we need to use it in the future, we'll just take that file and use it in our new project. That is what we're going to do. So we're going to make a math library. So let's get to our Linux virtual machine, and we're going to open up this Java file. We're going to open up a terminal. And let's get rid of the code from the previous video. I added this to Git just now, so it's up there if you want to view it yourself. And as usual, let's get rid of this import statement too. As usual, we make our project to make sure that it works, and it works. So the first thing that we're going to do is notice that we've been using classes already. We have class and we named it main startup. And you're going to see how we use classes. This is just take it for granted. Always start your Java programs and name it main startup for your legibility, and just put main in it. Don't put anything else if you don't need to. If you're using like one file just for everything, then just do that. But once you start using classes, be really clean and create separate files. So we are going to make a math library functionality. You saw that we used ArrayList, and that was really helpful for using array data structures. So maybe we want to make a math library ourselves so that in the future we can use it whenever we need to do certain functions, like do certain things. Kind of understand what I mean, hopefully. So we are going to name it the class source math library. That's our class name. And so obviously we need to make a Java file for that of the same name. That's just the way Java does it. So we created the file source math library.java. And inside of it, I'm going to type the code out with you. So the code, again, is on my website. Hopefully you subscribe to the video. You click below to get to this page. I don't know if I said that this video, but you can do what you need to do. So our class is called source math library. And we always start out by naming the class that. Class source math library, which is just the name of the class. And you'll see how it gets used later when we actually use it in main. For now, just take for granted that we're making some class that's going to have some math functions for us. Now, the first thing that we're going to do is we're going to create a private variables and functions. So our class is going to have, as I said, it's sort of a blueprint for the library. And what it's going to have is going to have some functions that we're going to use, like addition, and it's also going to have some private variables and some variables that we need to use. Like, for example, when we did ArrayList, there was a size function that returned the size of the array for us. That's like a function that you need to use and add to some classes if that's what your class needs. So what we're going to start out with is private variables. So we're going to have a private int that is named faveNum, and this is going to be our favorite number. So it doesn't make sense really for a math library, but for our example, it's really good. It's our favorite number, but we don't want anyone else to edit this. We only want the class to edit it, and this really goes into encapsulation, abstraction. There are a whole bunch of like object-oriented terms that you need to know that we're just going to naturally do it because it makes sense. We're not going to talk about it. And one of them is making variables private. And what private means is that only people inside of this class can access it. So it's sort of like, let's say you have a restaurant and you got the whole restaurant, but you've got the kitchen in the back, and the only people who should go in the kitchen are the waiters and the cooks and maybe the managers. And you have customers that use the restaurant, but you do not want them going into the kitchen for cleanliness reasons. Maybe they'll mess something up. Maybe you don't want them to see the secret sauce, something like that. Reasons like that are why you would have it separate, and you would only give certain people access to it. That's the same thing for classes. We're going to have some public functions in the classes that are going to help us out. But we also have some other helper things inside of this class where we don't want other classes or other users of the class to be able to access, because it might mess up our whole system, our whole class. And that's why you would use a private variable for it. So we have this integer named faveNum, and we're going to declare it private. And basically that's going to be our favorite number. Our favorite number. And we don't want anyone outside of the class to edit that. You'll see how this works in a bit. Now, everything else is going to be public. For now, we're just going to make this our only private thing. And you understand the reason. It should be the only... In our restaurant example, you don't want everyone touching everything. You only want some people touching certain things like the kitchen. And that's why you would create it as private. So the next thing we're going to do is public. And we are going to make a constructor. So source math library, and this is our constructor. Now we're not going to fill this in right now, but what a constructor is basically when you instantiate the class, a constructor sets everything up. So by default, our favorite number is set to nothing right now. But when you do want to set it to something, you want it to have a value before using any functions. You need to make sure that it has some stuff set up. So basically, constructors for classes are going to set the class up and anything you need when the class gets instantiated for each object. Remember, this is a blueprint, but you need to use that blueprint to create an object. So for example, let me see, what kind of example could we use? Let's say we have a blueprint for our house, and maybe it has some bricks, maybe we have a kitchen in it, and 3 bedrooms, and maybe every time you use the blueprint to build a house, there are certain things that always need to happen when you make the house, regardless of what the owner decides to choose to do with it. Like, you always need to put in plumbing for the house. Anytime you make a house, you need to put plumbing in. So you always have to set that up. So whenever you use the blueprint, you basically have this constructor that says, we need to make plumbing every time we build a house. So go ahead and set that up every time we instantiate. Every time we make a house, just do it, regardless of what the owner wants. That's basically what a constructor is. It sets everything up when the class is instantiated. And again, you'll see this when we actually use the class later. It might not make sense now. And the next thing we're going to do is, finally, we're going to make a useful function for us. So we've used functions before. You should understand what they are. This time they're sort of called methods. That's just the terminology. A function is just like a function by itself. A method is part of a class. Just remember that. They're basically the same thing. And our method is called add. So it is public, which means anyone who instantiates the class can use it. And it returns an integer, so that's the type we're going to give it. The function name is add, and it accepts 2 parameters, an integer a and integer b, and it returns the addition of them. Really simple, basic, but it's useful for us. And now we're going to make a few more functions. So we've got public int get faveNum. So we declared this faveNum up here, and this is going to be our favorite number, and our math library is going to store it for us. Now we want to make 2 functions, and it's always good practice to make your private variables inaccessible and to have them accessed through functions like the size in the array list. We couldn't get the function by itself. I don't know if you noticed, but we had brackets around the size when we made the size declaration before. Let me see. Let me get that up for you, actually. When we used the array list before, you see we had to use int n equals mylist.size, and that was basically a property. And you use these brackets, which means it returned from a function. And the reason you do that is because you don't let anyone edit the actual private variables. Because, like, imagine you have a list and you let one of the users of the class actually add to the list even though there's not an item there. If they added to this variable, that would be bad. So basically, you assume everyone's dumb and you're not going to let them access things they don't need to. That's literally exactly what it is. And we're going to create another variable, function, that sets favorite number. And it accepts a number. And okay, so let's work on this. So we've got this function named setFavoriteNum. It's type void because it's not going to return anything. It accepts a number named favorite. And what it's going to do is it's going to set faveNum up here. And the way you access it, since it's private, is you say this faveNum equals fave. So we're saying that anytime setFaveNum is set, the user of the class wants to set the faveNum, they will pass in their favorite number, and the faveNum, the private variable, we say this dot faveNum, which means this in this case is the class, this dot faveNum equals fave, and that sets the favorite number. So use this dot fave, this dot every time you need to access a private variable inside the class. Just make sure you remember doing that. This keyword is to do that. And yeah, and now we're gonna get faveNum, which is just gonna return this dot faveNum, of course. So these are our getters and setters, basically. Get the faveNum and set the faveNum, and you can see we use the this keyword and we just set the private variable. So that's private variables. That's really it. That's why you would use it. You don't want anyone else to access the faveNum. The way they do have to access it is by using these functions that we set for the people, because we decided it was important. Now let's also create one more function for our math library. Last one. And it is going to be a void that print faveNum. And this is just some nice functionality that we're going to do. We're going to print the faveNum ourselves. And you're going to see something a little special. So instead of saying this dot faveNum so we're printing something, right? And what are we printing? Well, we're saying get faveNum, and it's actually going to call get faveNum from inside the class itself to get the favorite number. We don't actually do this dot faveNum. We could do this, right? And that would be the exact same thing because it's returning this dot faveNum. But that's bad architecture, because later on maybe you want to do something with the faveNum, and you'd have to change the code here and here to make it work. It's always good to only access the private variables from the actual getters and setters. That's just the way it works. In other programming languages, it's a little different, but for now, this is how you use it in Java. So we're going to print the favorite number by getting it and then, calling it on system.out.println. Now, we talked about this constructor, and this is going to be the last thing that we do. As I said, when you build a house, you always need to install plumbing. Always make sure that gets taken care of. When you got the blueprint of the house, and you take it and you make it into an object by actually building the house. But no matter what kind of curtains a house owner wants, no matter what color bricks they want, anything like that, they always need plumbing. Always, always, always. So you always set that up in the house every single time. That's basically what a constructor is. Anytime we make this source math library, we always want a fave number no matter what. And so in our constructor, every time an object of this class gets created, we are going to set the favorite number to 7 by default. Now this is kind of stupid. It doesn't make sense because we're making a math library that is just like having a favorite number. But when you make like data structures that needs like arrays of items and custom stuff like that, you need to actually initialize those variables if they want to get used. And just anytime you want to do stuff, every time the class gets instantiated, use the constructor. Now what we're going to do next is we're going to overload this constructor. Overload constructor. Now we did not talk about overloading in functions, but basically overloading is you're going to create the exact same constructor. And you see it's got the exact same thing. This should actually throw an error. But what we're going to do differently is this time we're going to allow a parameter to be passed to it. So this will let the user, when they create the class, set the favorite number right then and there when they instantiate the object. So that's overloading. Basically, overloading means you have two functions with the exact same name, but the parameters are different so that you can do different stuff depending on what the user wants. And for example, we could even have an overloaded add where we can add three numbers in C, and we can actually return a plus b plus c. So again, if they wanted to do if the user wanted to add two things, or they wanted to add three things, they can call the exact same method, but they can pass different parameters depending on what they need to do. And that's really useful, especially for like different data types, like if you wanted to do long, or there are a lot of different things. So being able to give them the same functionality is good programming. The reason you use objects most of the time is because you're building something big. This isn't like some quick functionality like you're doing a quick calculation. Building classes is because you're building a big structure. So we are going to use our overloaded constructor, and we're setting the favorite number to whatever fave they passed in, whatever integer they declared. Now, that's it. That's our class. Let's give it a quick look really quickly. Class source math library, same as the Java name. We've got a private integer named faveNum that only these guys can access. We've got a constructor that sets the favorite number, and we've got set faveNum and get faveNum, which does stuff with the favorite number for us. It facilitates the transaction. It's the middleman. We've got one function that's add, and that returns the addition of two parameters that gets passed to it. And we've got an overloaded constructor in case the user wants to set the favorite number themselves. When they make the object, then they can do that, which is just easier some of the time. It's just ease, personal preference. Obviously, you could just instantiate it and make them set the favorite number in a separate line. But, with programming, you got to be a little complex, and you got to give the user as much as they want to do. So let's go ahead and make. Should we make? I don't know. Let's not make yet. Fine, let's make. I don't think anything changed, though, so it should be fine. Now, we're back in main. And our class library, our source math library class, we want to use it. And it's part of the project, so it'll probably get compiled anyway. So what we do is we say, okay, the same way we used array lists, we're going to use the same functionality. We're going to declare a source math library type, and we're going to name that variable math. And what we want to do is we want to make the object. We want to turn the class blueprint into an actual object. Imagine having the blueprint for a house and actually turning that blueprint into a house itself, onto a piece of property. So the way you do that is you say new, you create a new object for it, and you say my math library. And you instantiate it with these brackets, which basically calls a constructor. And that's the way it works. Now, you don't need a constructor. Actually, that might not be true. You might need a constructor, but basically that's how you instantiate the object. So we've got this math object that is the object if you use the source math library blueprint, which is the class. And I know I'm talking about objects and it doesn't really make a lot of sense right now, but when we go into the next video, what we talk about derived classes, it's going to make a lot more sense. So for now, just take for granted that this is how you use classes. I'm trying to say a lot because when I learned it, it didn't make sense to me, but if you hear it, you might understand a little better the more people talk about it. So we've got this object named math, and it represents our math library. So we can do certain things, like we can call methods on it. We say math dot print favorite number, and that takes our math object and it calls the print favorite num method. And then we can now print favorite number right now, what should it be? By default, it's 7. Now let's say we want to change it. Well, we can use a set faveNum method, and we can pass it 200. Now what happens is the 200 gets passed to the set favorite method to this infave, and that becomes a favorite number for the whole class, which is crazy. So remember, one of the points of class is that it's an object and it has a bunch of functions and variables working with it that can be stored, basically, and that's useful. So we're setting math's favorite number to 200. And we will print that. We'll print it, and next we will create a variable named addition, and let's test the add function. So we're going to do math.add and 2 and 2. We're going to add 2 plus 2. And let's print that. Did I say out? I didn't say out. That print line, and we will print that number. And let's make this. So we did not change our make file, but since we're using math library, it should get compiled to. I don't understand, to be honest with you. It's a little weird. Normally, in like C++, you need to declare the file to be compiled to, but you don't need to for some reason. So our favorite number started off as being 7. We changed it to 200, and it prints as 200. Then we add 2 plus 2, and the addition variable turns into 4 because that's what 2 plus 2 is. And yeah, so we made the class, right? And that's really useful. But before we finish up, I want to create another math library object. So again, this is our class blueprint, and we create an object with it. So we're going to create another one because you can have as many as your memory allows you to. And we're going to name this another math. And it's the exact same thing, except this time we're going to use the overloaded constructor. Instead of leaving this part blank, we're going to use this because we know that our constructor can be overloaded to accept this integer named fav. And what it's going to do is it's going to set the favorite number by default in instantiation. This line is called instantiation. We declare the object, and then we instantiate it using the new keyword. So we're going to create our favorite number and say it's -1, and we are going to print it. How do I say this? So you can still use math down here, because that's the object, and it'll still have 200 as its favorite number. But remember, that's a different object than this. Think about these as objects. And when we go in the next section, it's going to make more sense. I keep saying that. So print faveNum. And let's make this again. And we should see -1 show up because another math's favorite number we set is -1. And that's why when you call print faveNum for that one, for that object, it's going to show -1. So that is classes in Java. Again, a class is just a blueprint, and you use it to create an object. And this object has certain properties that you declared inside of the class, like the add function we made, a method. It's a method, so you can call it onto this object and do stuff with it. You can also have private variables that get carried along, or even public variables that get stored as part of the object. And the reason you would use objects will make sense in the next video, but just this is how you use a class. If you know how to use a class and understand everything that we just went through, you're on your way to learn object-oriented programming. That's the syntax of classes in Java. I hope it makes sense. I'm SourceMake. Make sure you watch the next video to further understand how all this works.